Hi everyone, this is Xueying from Lincoln University. Today I'm going to talking about the research of treating farm dairy effluent with poly-ferric-sulphate dramatically reduce phosphorus and E. coli leaching through subsurface drains. The background of this research is that land application of farm dairy effluent may lead to water contamination by contaminants such as phosphorus and E. coli, especially through artificial subsurface drains. A new FDE treatment technology using poly-ferric-sulphate has been developed to recycle wastewater in farm dairy effluent for washing the farmyard. A physical drainage model study was conducted to investigate the effect of treating farm dairy effluent with poly-ferric-sulphate on phosphorus and E. coli leaching through model subsurface drains. The objective of this study is to determine the amount of phosphorus and E. coli in drainage water following the application of poly-ferric-sulphate treated farm dairy effluent compared to the application of untreated farm dairy effluent. The hypothesis of this study is that the concentrations and amounts of phosphorus and E. coli in drainage water from land applied with poly-ferric-sulphate treated effluent are lower than those following the application of untreated farm dairy effluent. In this research, 20 drainage models were collected and installed in February 2020. Effluent was collected, treated, and stored for 8 weeks as TES. Fresh FDE was collected and treated by poly-ferric-sulphate on same day of treated application. 4 treatments: untreated farm dairy effluent, fresh treated farm dairy effluent, stored treated farm dairy effluent, and water as control, was applied twice in 2020 with 5 replicates in a randomized block design. Herbage above the drainage model was harvested, dried, and measured for plant dry matter yield and analyzed for total phosphorus and nitrogen concentrations. The results of this study is that the concentrations of total phosphorus, dissolved reactive phosphorus, total dissolved phosphorus, and E. coli concentrations from the application of fresh treated farm dairy effluent and stored farm dairy effluent was significantly lower than those from untreated farm dairy effluent application. Cumulative DRP lost to drainage water from the TE and TES treatments were 93.1 and 92.2% lower than those from the FDE treatments. Compared with FDE treatments, there was a 98.3% and 99.9% reduction in E. coli in the drainage water from the TE and TES treatments. Plant biomass and phosphorus uptake were not affected by effluent treatments. The main conclusion of this study is land application of fresh or stored poly-ferric-sulphate treated farm dairy effluent can significantly reduce phosphorus and E. coli leaching into waterways through shallow tile drains compared with untreated farm dairy effluent. And the effluent treatments with poly-ferric-sulphate can serve as an effective tool to help protect the surface water quality by mitigating phosphorus and E. coli entry to waterways from farm dairy effluent. The environmental benefits can be achieved without adversely impacting pasture production or quality. We thank Lincoln University, the Ministry of Business, Innovation and Employment, and Ravensdown for funding. We also thank Steve Moore, Trevor Hendry, Roger Atkinson, and Shiv Prasad Pokhrel for technical support. Thanks for watching.